Welcome to this video, the conclusion of the normal curve. And this video is going to talk about how do I know if my data set is normal. And hopefully you're thinking, well, first I should look at it, which is an excellent place to start. So we should always graph our data. Histogram is probably the best way to look at the shape for this, what we're doing here, to see if it's approximately normal. Um, but that's not enough to say your data is approximately normal. So then we have two methods we can use to check if our data is close to normal or not. All right, so here I have a data set from our book. It's the unemployment rates in 50 states. This is old data, but it's all 50 states, and we want to know if this data is approximately normal. So we're going to test using the 68, 95, 99.7 rule. We want to see if this data follows that. So if we have the mean and go plus or minus one standard deviation, do these data points, do 68% of them fall within that range? And then if we go out plus or minus two standard deviations, do these data points fall in the 95% range? So let's start off with our plot. And this is what the data looks like plotted. And it's a fairly decent, approximately normal for raw data. Yeah, it's not perfect like you would want, but there's one peak, it tails off at the ends. It's enough to go forward and say, let's test this out further. So I went through, calculated the mean. It is 8.682 and the standard deviation. So then I need to make some fences, we'll call them, by doing 8.682 plus or minus that standard deviation. And then I'll do plus or minus twice the standard deviation and plus or minus 3 times the standard deviation. And these are the ranges we will get. So then you go back to your data set and count how many unemployment percentages fall between 6.457 and 10.907. Feel free to go back and satisfy your curiosity if you want and count them up. You should get 36 out of 50 or 72%. Then you would go and see how many are between 4.23 and 13.132. You should get 48 or 96%. And then lastly, how many between 2 and 15? That's 100% of the data. And if you look at these percentages, they match pretty well with the empirical rule. And it's not going to be perfect. It's data. Nothing's going to match exactly what's there, but it's close enough to say our data distribution is approximately normal. All right, now you might think to yourself, that seems a lot of tedious work, and if I hadn't done out the work or the book hadn't done it out for us, it would have taken us a lot longer to go through that than what I just did. So there's another way to do this, which is called the normal probability plot. And it takes your data, which is in your calculator, and lines it up from smallest to biggest. And then it figures out, based on its position in that data, what would its ideal z-score be. Then finally, your calculator graphs it, and if it looks linear, the pattern of the scatter plot it graphs, your data, you can say, is approximately normal. All right, and these are some views of what it would look like. So here is what a normal probability plot that's approximately linear would look like. I also have graphed on these the box and whisker, just so you can see, yeah, the box and whisker on that looks symmetric. And over on the skewed ones, you can see this definitely looks skewed to the right versus this one looks skewed to the left. And if you have skewing, you're going to have this curve going on. And then finally, we have one that has possible outliers. We don't know. We'd have to go back and do our IQR check. But these, because you have those ones stacked in the middle, it could be that those end ones are too far out and are making it appear more stacked than it actually is. So you have to go investigate this further. All right, let me show you how to do this in your calculator. So we have a list of made up test scores on a chapter 1 test in my stats class. We're going to put this into our calculator, and then I'll show you how to graph it. All right, so bring up my calculator. All right, so let's say we're on our home screen here. The first thing we're going to do is go to one of your favorite menus coming up, which is the Stat button, and we are going to edit. Now I've already put in the data here, and I will scroll down a little bit if you want to follow along and type these in as well. If you already have something in a list and you need to clear it, you want to go up to highlight it using the arrows, press clear, and then enter. And that will clear the list. If you press delete and then enter, it deletes the list from existence. I can show you how to get it back in class one day if it goes away for good on you. All right, so let me go down so you can see all the data, and you can pause if you need to. I think there's 2 more. Yeah. All right, so pause it if you need to enter the data. And now we are going to graph this as a normal probability plot. And if you want to do that, first thing I suggest is always just checking this y equals button, because if you're taking calculus or pre-calc, you might have a regular polynomial typed in here. You want to make sure it's all clear, otherwise you'll have weird graphs. All right, so we want stat plot, which is right above the y equals and in blue. So you're going to hit the second and the y equals button. Now you want all the plots off except the top one. And the way to do that is if you have one of these that is on, you can just press enter and toggle it on or off. So you move the arrows and press enter over which one you want. All right, so I would press the up to get to plot 1 and enter. All right, and then we have types of graphs. This first one's just a regular scatter plot, XY coordinates scatter plot. This is a line plot, so if you're connecting your lines. Histogram, box and whisker with the outliers taken out, so the calculator does the IQR calculation for you. Box and whisker not checking for outliers. And then the last one is your normal probability plot. Then you have to press enter on that to select it. And then your data list is L1. And then it asks which axis you want to put that on. I just default to X. Different books and publications put the data on X or Y axis. It's not critical for you guys right now. Just know that if your data looks linear, it's approximately normal. And then you can pick if you want to do pluses or filled in dots, whatever you want your graph to look like. All right, then we're going to go to graph. Now, if your graph did not show up like mine did, and you're like, I set everything up and you just have a blank screen, a lot of times when we do stuff in statistics, the zoom is not set up right. So you want to go to zoom and do number 9. You can either press 9 or scroll all the way down and press enter. And that will center it around your statistical data. So if you just had a blank screen, try that, go to zoom 9, and you should get this data, which looks approximately normal. And you can say your data set is approximately normal at this point because the normal probability plot appears linear. I thank you for watching, and I hope this helped you out with your calculator.